So am I live? There we go. And there. I think we should be live. Let me just check the audio, because last time I saw on the... I think we should be live. Let me just check the audio, because last time I had a few problems with the audio being too loud. So I think we should be live. Let me just check the audio, because last time I had a few problems with the audio being... Yeah, okay, the audio works, I hope. So let me just check. Okay, yeah, no, we should be good. So the live stream, the chat is working, everything fine. So today I wanted to redesign again the motor mount. Last time I printed the pieces. Let me just here, OBS on the side, so I can actually control everything in the stream. Oh, everything is tight enough. So here the motor mount, I printed this last time with the improved knobs on the back. Yeah, you can see you can see it kind of in the stream. You have those little holes in here where the nuts go in, just like that. Wait, let me just put one in. But I had the problem, or didn't have the problem, I forgot to rotate it correctly. Let me just open the door. I'm back. So the live, can I see the chat on the side? Yeah, I think I can, like this. Damn, those YouTube extensions for blocking all the videos are blocking too much here. Yeah, then I'm watching on this side. Also works. So yeah, what I just said was the nuts go here in the motor mount in the back, so you don't have to need those extra tools to tighten the nuts from both sides. Usually they stick there in quite well, so you can... Oh, kind of works here. It sticks in there. It's not that tight, because there's only like 0.5 millimeter of space to the hole here where the motor goes through. So yeah, that's... have to see if I can improve that. Also, if you stick the motor in, the motor has a lot of space in there, so it actually doesn't even need that much space. I just gave it like those... It has here, you can see it, it has an extra 5 millimeter, no, not 5 millimeter. Yeah, the measurement tool. Let me just check how much that even is, because it's a bit too much. You don't need it really need that much space there. You shouldn't have any space there. Yeah, it's around 2 millimeters. So the thing is, because you want to slide the motor in from the bottom, and I couldn't figure out a way how I could slide the motor through it, but the cable is here, so you can't just put it in like that because the cable is in the way. So I had to give it some space that I can, a bit more space that I can rotate it like that, and then I need to add a few millimeters that the horizontal bar needs to go through there. Yeah, stupid mess, but maybe I'm just didn't came up with the best idea to rotate it, but that we don't have to worry about from now on, because today I will design, or I already have a few designs in my head. Just need to make a few sketches on what I want to do, because this is kind of stupid to put the motor behind like that. It's not kind of stupid, but it's a bit unnecessary, because I can just stick the motor in like that. The problem with that is you have those little parts in between, those little triangles there, which I have to model out by hand. So I have to build some holes in there that I can't stick it in much further than that here. So that will be modeled out, and then we don't even need the nuts. I saw in a few other robotic arms that were 3D printed, or just in general, they didn't even bolt it in the back of those nuts. They just screwed them in, and my experience with that, it was still very strong, because you make the holes just a bit smaller than the actual screw is. So if the screw is 2 millimeters, you make the holes 1.9 millimeters or 1.8. So you have to screw the screw. But let me just screw pattern. Screw pattern. Is it called like that? I don't even know the German name for it. Right here, let me just see. Now this. I think you get what I mean. The pattern where the screw should go in. Take a look at that. The hole is usually completely round, and those screws have a bit of a rough side, so they hold onto the objects. And when we can just make that ourselves by screwing the screw in. So I will try that. If that doesn't work, or maybe it will probably work, but I think there the error is that where I could run into problems is when I use the robotic arm and assemble it and make a few changes, and then I have to unscrew everything and then screw it in again. It will become loose, so that might be a problem, but we will see about that. Right now I'm just prototyping anyways, so I will see if that is improve worthy, or if I need to improve much there. But yeah, so as I said, today I at least want to get done the motor mount again, like the last 5 streams were. So I think we need to get started, that I can get maybe a few more things done today. But this will be our main focus, that we finally get the motor mount done, so that it will hold and I don't have to design or come back to the design every single week. So let me just open up all of the projects here. Wait, where is my robotic arm? There, the V2. Let me just stick it up like that. There, V2. And now we just want to open we're making a new motor mount completely from scratch. Scratch. One there, and then we'll also open up the old one on the side to have a few reference images or that we know the sizes of everything. So let's see where the base sketch is. No, that's not it. That is this pattern right here. This also not, it's again that pattern. That is a bit closer, but still not what we want. That is what we want. You see, this is our little drawing right here. I think the motor mount here is actually 70 millimeters wide, or the motor itself is 70 millimeters wide, and I gave it there a bit 2 millimeters more space, which we won't need for now. If it fits tighter, maybe we have to hammer it in a bit. Have to see if the 3D printing parts will break if we make that, but we won't worry about that for now. We will start by going into our unnamed file, and we will call this motor mount v2. And the next thing is, we don't even need that, as you probably heard from a lot of people say, the best part is no part. So my last ideas were that I just print out the motor mount, screw the motor in, and then I screw the motor mount again on the base plate. This is my old plate right here, and just have some screws that go through here. Then I have to need another 4 screws. Then I have to look how I rotate this part on the 3D printer pad, so it will print everything correctly, because as you can see here, the back side didn't print correctly because I printed it from the side, and you can just print out the air, or you can, but then the print will turn out shit, or it might even be destroyed. So I have to see what I will do there. Wait, here's an error. Wait, they're telling me my streaming is a bit whack here, YouTube. Wait, they're destroyed. So, I think it's fine. YouTube just gave me an error message here saying that it doesn't really receive enough video material. But I hope it's fine. If you can maybe tell me if it's fine, or if I can look if I have any wrong settings in OBS. Anyways, so the best part is no part. So my next idea, after I printed the motor mount and tested that it is actually fitting, I will stick the motor mount directly on the base plate. Then we will probably have to print the base plate on the sides, but we will see, and I think that would even be the better idea. So just one print, and will just be a larger print, because now we have to print the horizontal axis to then print the holes correctly, or we have to shape the holes differently so the 3D printer can print them correctly. Yep, we will see about that. So now what we want to do from the start is we want to get this right here, and then I want to go back into my motor here. The sketch is free to use there. X and Y plane, maybe it would be good to first start. Let me just see how I can. Let me just delete them again. Wait, can I delete them now? It's like that. So I want to make a new sketch. Sorry, I had to go into the part designer. There I can create a new body, create a sketch. Just click the X and Y plane. Just close out of there, so I have my little body there. Then I will yep, this works. If I delete that part, this will hopefully still work. Here we just make this 40.5 millimeters long. Then we should have the original size of the motor, and then what we should have, if we go ahead, delete that real quick and scale this up. We want to scale it up. Wait, let me see how big the motor actually is right here. Just roughly, you can scale it up. This side is better because it's giving you 7 millimeters. So if we want to screw in, give it a bit of space, give the screws a bit of space. Let me just see what kind of length we have here. We have 8 millimeters, 12 millimeters and 4 millimeters. 4 millimeters is way too small. If you look at it right here, 4 millimeters, that's nothing. So that won't work. 8 millimeters is better, but still a bit small. Oh yeah, we have to see that the screws get in from the bottom below the pad to up here. Yeah, that would be 1 millimeter if we go from here to the top. So let's just make that 10 millimeters in height. And then the next thing that we have to do is select this one, create a sketch on top of that, and then we just drag out our 2 reference points from the other sketch. Let me just scale here the YouTube again so I can see if somebody writes in the chat. Here, thank you YouTube. So, okay, maybe it's not the best idea to watch the stream on the side because then the Wi-Fi will be worse. So, motor is done. Now we have to carve out those little triangles on the motor here so we can put on the... Wait, no, wait. Yeah, the pad is supposed to be... I mean, we only have from here to about here, that is 8.5 millimeters long, so like that, and then the sketch is still that height, perfect. Here the top. Now when we go ahead and draw our little rectangles from here to here, their width is about 2 millimeters, so we give them 2.5 millimeters. Yeah, 2.5 should be fine. So we go like that, 2.5. Oh, that's... I forgot that I have to make this accurately to the... I can't use a dot, I need to use a comma because I'm still in the German diameter, how do you even call that? The German system, metric system. So 2.5, I'm just saying point because it's easier than comma, and I'm used to saying point. So this is the length. Is from the center to out there, that's good, but the length of it is 5.5, or the height. Let's make it 6. And 6. So now we drag all of that out to be easier readable. Then we have to define the center. From this point to this point. If we take a look how long this line is, it is 20.5. 20.5 divided by 2 is 10.25. 10.25. And then from that we have our 2.5 millimeters on there. Minus 2.5 divided by 2, which is 10.25 minus 1.25 millimeters. That is then right there, that is 9 millimeters. That's almost correct here. Let me just remove that constraint again. Just 9 here. Then we do the same for the bottom. There we will have same from this side to this side. That should be 9. Perfect. Just like that. So really easy. If we now click close and we press remove, we want to now carve this hole not completely through, although that would be a bit easier. Let's carve it 5 millimeters, just like that. That should be fine. So that should be our new hole. Let's still run the screw completely through. Because I don't want to make all the screw sizes again, because I already made them here. I could also duplicate the sketch right here. Let me just see if that would work. Yeah, and then paste it in again. Delete. No, I want to again make this under the body. Then here delete. The sketch 2 is the... Let's just rename them. Bottom. I have to also get in the flow of naming my objects here, just like I used to do in Unity with game programming, because if it gets bigger and if I send you the files later, I don't want you to, or I want you to have an easy time looking through those files if you need to improve anything, if you need to change anything. So the next thing we would have to do is how do we call it? Triangle holes. I think you get the point. And those will be the screw is called differently. Screw with double E, I think. Picture. Yeah, okay, it's spelled completely different here. Screw like that. So if we go ahead and take a look at that, we don't actually want those lines out here. those 4 lines, we can just delete them. Then we can delete those lines. Delete. And now we can just go ahead and delete those holes from here. Pretty easy. Then this should still be fine. Oh, let me just close this console right here. It's always pissing me off if there is Python code in there. Nothing against Python, but if I'm doing any modeling here, I don't want to get any Python error messages if I'm not programming directly. So we want now this sketch to be displayed the screw. That's good. Now we have that on top. I just quickly want to delete that extension right there, which means I need to redo that. 8.5 millimeters I said was there. Oh yeah. Oh no. So we have this. Now that are the triangle holes, but I want to have this up top. Okay. Can I change their bottom? Oh no, I completely messed it up. I just undo all of that. So if I just stop this right here, the pocket, delete. Now where are the screws? The screws are up here. Delete those points that I don't need. Then on the bottom I want to scale this up to 8.5. I think I didn't press scale, didn't press here pad, I pressed pocket here, so that's not how we want it. So here we press pocket on that one, we set 5 millimeters there if you don't I can remember, yeah, it was 4 millimeters actually, but 5 millimeters was the better thing. So still have some space in there. So when we now screw it through there, we have 1 millimeters. If we use the 8 millimeter screws, this is 8 millimeters long. There will be also an additional 2.6 millimeters added there. So in total we have 10 millimeters. So let me just make that hole 8 millimeters wide, deep, and there we have our part. Hey, if you watched any of my previous streams, maybe you are new here, I don't know, but in my previous streams I struggled a lot with the interface here, but that's, I mean, I started here with FreeCAD 2 weeks, a month ago approximately. When I first downloaded it, I didn't use it every day, mostly just when I was streaming. So you see how often I streamed in the past month. So didn't use it that often, but it is just about repetition, and you just have to, if you want to learn a software, if it's game development, if it's Unity, if it's Blender, doesn't matter. You just have to be a bit consistent on it and just learn it. And I'm definitely not good at 3D modeling. You see here I probably took... How long have I been streaming? I think for... Can I see that right here? Yeah, for 20 minutes approximately. 15 minutes of that, it took me to make this... It took me to make this object here right now. Probably still way too long, but a month ago it would have taken me like 2 hours to create that. So, as I said, just if you want to learn something, you just keep on doing it until you can it, or be better at it. And to be a pro, you just have to spend a lot of time in the software. I think the you generally go from about 10,000 hours to be a pro at something. So 10,000 hours at a repetition, and you can be a professional in that field. So yeah, you know how much I have to stream learn now. So that is our part, and I want to print it now. If I want to do that, I will have to go into the export, or in the file, and press export. Sorry, I didn't select this body here now. Export, and I want to, okay, again as an OBJ, Robotic Arm V2, new tests, motor mount V2, leave the object out of there, and then I hopefully have my 3D printing card up here. Yeah, SD card goes in there. It's my last print. Let me open Cura again, Ultimate Cura. I'm probably spelling that a bit different, but yeah. So motor mount V2. Cura takes its time, as we know by now, to open. Let's just leave it there for, say, I say it takes 2 minutes to completely open. Maybe I just have to update it and all of that goes away, but yeah, I think it updates itself. If you know why it takes so long to open it, maybe it's because of me, because I didn't specify that it is allowed to use enough space on my PC or enough and calculating power. Or maybe it is because the software is just too slow. I don't know. Other softwares open more quickly with more functions. Up 1 minute approximately, so Cura wins that one. So let me just go ahead, put the motor mount in here, look that it's in the right direction, so like that. 10% infill, 40 minutes with 10%. How much is it with 35? It's 4 minutes longer, yeah, okay. Then I will add a bit of infill, even though that is just the example part. So what we can do now is save it to my drive. Oh, yep, I ejected it already. So by now you guys know that if I have something in my SD card to print, I have to go and print it now. So 2 minutes and I'm back. See you. Not even 2 minutes. Fast as fuck, boy. So let's just close all of that again. And if that should work, we can just put that on top of the base plate. We just open it. Base plate right here. You see, last time we also already made some holes. Let me just rename all of those. I think that is the base, and that should be the side overhang, and those should be the screws, which I want to remove for now, because the second I want to just add my little servo motor on there. There's another thing I thought of. How do we actually assure that the stepper motor right here actually stays on the so that the stepper motor actually stays on the plate, because of the plate the robotic arm is lifting something right here. It should not have the space to tip to the sides. No. I think that should work, because this is a lot more space here, and that's why it's able to tip here. You can see it has a lot more space. Next thing is, in the end I want to print it like that. So this is the base plate, then I want to put the print on like that. The holes will be pointed like that, so that the holes will be pointed upwards. Sorry, like that. Then we will have some support right here. Just have to forget about these parts. So support right here will all have to be removed, and yes, also the sides. Then the next thing, which could be a problem, is that it needs support for printing those rings right here, because they would stand like this on the plate, and I hope that it doesn't put support there, because if it does, it would be a pain in the ass to remove all of that, and then you would rip just the sides off, and then there would be like 2 hours of printing time plus that are unnecessary. So maybe we have to see if we can remove that material there in the printer, if it should make some supports in that area, or if we can just put the object itself to the sides. But then the screws wouldn't be, or the motor mount wouldn't be accurate with the screws, which I don't want. I mean, it's higher up in the air if... No, it's not high up in the air, but if it's... the higher it goes, the more inaccurate the motor gets because of wobbling. I mean, the base plate is driving around, and it might not be visible to the eye, but there will be like 500 of those layers, as you can kind of see right here. They're reflecting 500 of these layers, and if the 3D printer should 0.5 millimeters every time it prints, should wiggle in one direction and offsets, you can imagine how that would affect a print with 500 lines upwards, with every print being around 1.5 millimeters inaccurate, so it wouldn't be inaccurate always to the sides, but just left and right, and then the holes, if they would be printed up here, would be inaccurate. I think you get the point. So yeah. The next thing is actually that I want to start with the arm itself. We made some designs last time, so let me just check that. So we have our nice folders right here. We have this sketch right there, which I made, and this sketch right here. So this was inspired by my last sketch and a other robotic arm that I saw. Wait, you can't really see it like that. Bit like that, other than that the side is switched. This is kind of wobbly, if you see it like that, especially if the motors in the end should be on here and everything. Does it even fit on there? Of course it does not. You can put it in. It would be a lot of wiggling around, so I thought about making it a bit thicker in length. Would add a lot of printing time and also a bit of weight to the arm itself, which in the end means it's not able to move as fast, but is a bit stronger. So we have to see the trade-offs. And also, if somebody doesn't directly have a 3D printer, he wouldn't be able to make that in like cardboard or something. But either I have to sacrifice that idea that you can make it with cardboard, this 3D printer. I mean, I would lose a few people who can't afford or don't have a 3D printer and don't want to buy a $300 3D printer just for building a robotic arm. But I think you get the point that I have to see what the trade-off would be of making it a bit thicker, adding much more printing time, and the stability of the print itself. So either we go with that idea, which is a bit thinner, a bit thinner in height, so maybe double the height of that right here, or we really go with this bigger idea, which would be then 3 times the size, which then in the end would be just a square diameter from this side right here, and just imagine that length, that height also in that direction. And just the motor being able to mount it like that. So also a bit more space to the sides on the top part. But yeah. So if you guys are watching and listened, maybe you can say what you liked more. Maybe if you watch this in the videos later, you can and have a bit more ideas about robotic arms than me. You can maybe tell me what the trade-offs would be better, or what you think should be better for this robotic arm. For now, I think it wouldn't hurt to try to model more things, not more things, but model this thick one, because I think we can remove it in the end, or would it be more practical to design the small one first and then move up to the big one if we can just extrude it a bit more. I think I first of all will go with the thick one. The thick one is a bit better, and I think in the end looks better if we have those big motors, and then yeah, we'll find a mix. So what we do now is the arm. So it's the joint 1. And for that we are in the designer again. We create a body, create a sketch, select our plane again, Then we just give it a simple outline on how we want to make it look like that. That is this part right here, without the hole for the mounting point and without the without the motor mount, so just this part. Then we will let's just scale that first. So this motor is in length 20 millimeters, which is 2 millimeters long. So let's just make this 3 centimeters wide. Which is 30 millimeters. And I think in length we last time said that we wanted, that was I think 20 or 18 millimeters. I think 20 is what we said last time. The motor mount will take a 6 on itself, and the base mount will probably also take, like, let's see here, this one needs to be mounted to the motor. This will take around 4 millimeters. It is 10 millimeters which is removed from that. So 10 millimeters is what I think we should have on the height. Sorry, I also didn't switch back to the view. If we have this rotated, I think do I have still Cura open? Let me just look how big my 3D printer can even print. Anicubic E3 Mega, plate size like that. It is 230 by 230. So I would say that maximum 20 millimeters in length. So then we have to make this 10 millimeters. Yep, 10 millimeters it is. Wait, can I see the size here again to just be sure? Which printers? Machine settings. Printer setting, yeah, okay, yes, also 210. So we shouldn't go higher than that I have to rotate it on the y-axis, I think they use here. Anyways, so the height is 100, like that. That would be scaled up in a second. For this side I also took 3 millimeters. So from here on out I will go with my motor V2 mount. Let's just go into the bottom right here. 30 millimeters, that fits. Let's close that for now. Hope we will need Cura again today. That would mean, if we need it again, that I will be finished with this part here, with the first arm, to test it out. But now I want to add another rectangle on top, which is from this rectangle bit to the top. So let's just size that up again to 30 millimeters, and in height that will have to be, let me check, and one, and the bottom that needs to be 60 millimeters, around 60 millimeters. I'm just thinking if it's smarter to, if it might be smarter to not make the rectangles directly on there, but extrude it upwards and then add the, yeah, let's just try that. Just see how this goes. So there we go. Then we will scale this up another 30 millimeters like that. Oh, that's thick. Then we will select top is right up here, the top. And then like that. On here we will scale this up 60 millimeters. And now we will select this face and we will create a new sketch. After I select the center, then this one will be a new sketch, which will take this and this point right here into account, and in the center of those we want to create our rectangle. That rectangle motor mount, we can close that in the base plate for now also. Click close here, motor mount. Take a look at the bottom again. This is 20.5 millimeters. Let me just see if the 3D print is going well. Yeah, the 3D printer is running perfectly fine, so no problems there. Let me just close that, my notes right here again, that I don't destroy them whilst I lean with my hands over them, with my arms. So 20.5 on that. .5 here. Then we will add 40.5. I could have just remembered that from earlier. And then here 40.5. Then this will be scaled from here to here. As we can remember, this was 30 millimeters long. So that means, just make some notes right here. This is 60 millimeters, 30 millimeters long, 50 millimeters if you divide it by 2. Then we have the other part, which is 20.5 millimeters long, divided by 2 is 10.25 millimeters. And if you take that away from the 15 millimeters, which we have from the left, we have 4.75 millimeters, and that is the center. Perfect. So that is fine. Now we have the same thing with the 60 millimeters, which is 32 millimeters divided by 2, minus the 40.5 millimeters, which is 20.25 millimeters, which in turn is equals to 9.4, no, not 5.75 millimeters, just from here to here, which is 9.75, like that. Like that. And now I have a slight problem. Nah, it's fine. So this will be through all, like that. And now we have the face from top. Let me just quickly rename that right here, which is the motor hole. And on the top we create a new sketch. Which takes this from here to here, which is 30 millimeters wide, and the height is, what did we say before? 8 millimeters needs to be the motor mount to be stuck on like that. .5, that means this has to be 21.5 millimeters. So now we just exit out of here, click remove again, and then here we press 60, like that. And the motor will be mounted in that part right here. Which means the motor will be in there. Now I will take a quick look at my notes again. Hey, what's up? Pixel test. I actually can't tomorrow because I have a driving lesson tomorrow. I just booked one because I want to have it finished, and then I will just grind out this robotic arm and new YouTube videos for the next time. So nothing going on tomorrow. If I would have come, I would have gone the whole day, because I want to do it the whole day and not just for 2 hours driving there, 3 hours long, and then driving 3 hours back. It's just not worth it. Just to go eat something in Frankfurt, can forget it. As I said, if you have a plan what we should do, I will come. But if you have to work anyways, and you just can't, or you can just... What? I don't can driving my eye test. You shouldn't drive your eye test, but I get what you mean. Yeah, you just have to wait for your glasses, man. But you'll get it. You'll get your glasses, and then you can start driving too. But yeah, so we have our parts right here. I want to now copy the holes from the last point. Just copy. Go over to our body again. Select this face. Put those nice screws in the body again. And then we select the face again and select our screw. And then if everything should work, we should be able to say that the screws should go in. What did I say? 8 millimeters? What do you mean? Now you didn't buy your glasses or what? And you can't do your driving test at all. Wait, no, that is now on this part. But I don't want it there. I want this to be projected on that part. Which means screw. So I guess that doesn't work like that, sadly. Delete that. But why? What do you mean with they don't need anything? Yeah, I've eaten green sauce at some point, but I think it's some time back. But I won't drive 6 hours just to eat some green sauce. To even call it green sauce. Green sauce, yeah, it's
green sauce.
yeah. So you call it like that, bro. I don't have any classes, so please just. What the fuck is deep tin, and is 0.25 much or not? But you can do your driving test if you don't have them, or do you just quit driving now? Can I move them up somehow? I guess that's not working. So I will just make a few reference points here, 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 and here again, like I did before. Then we will add our nice holes in there, just like that, that, and that. A bit too big, but doesn't matter. Then here, these were 3 millimeters wide. Yeah, that should be fine. Three millimeters, and also 3 millimeters, and again 3 millimeters. Then I want them to be separated 10 millimeters, 10 millimeters. There are a lot of ants in the sentence. That sounds good because a lot of ants. We would do a lot of stuff, but I don't think that's worth driving 6 hours there. Nah, I want to do something fun, not just eating and then drinking wine. You know where I only drink wine, so not just to drive back 3 hours then. So from this side we also take the stands from the last point. 20.4 was that. Oh, a lot of math. So the half part from this to this was 9 point. No, it was 10.25 millimeters. If you divide that by 2, we would have 5 point... no, I'm not doing that in my head. 10.25 divided by 2 is equals to 5.125. So now we would just select one end like that and one end like that, and then we just select 5.125. And then we have that centered. Then we do the same thing for this. 5.125. Yeah, I'm not sure about that. Wait, let me just see. Yeah, no, it's 5.5% alcohol, so now I'm out. I need my brain points for this kind of stuff here, so that I can still calculate my divided by 2 sentences. But as I said, if we do anything fun like go-kart driving or something like that, I would be absolutely in there. I searched up a few go-kart driving places yesterday in Frankfurt, but they all cost like 60 euros for 10 minutes of driving. So I think we both could have done that, but Moritz and so wouldn't be able to afford it because they're still in school. So yeah, I would be down for doing something like this, or some lost places as I wanted to do earlier. I also found a few Google Maps, or I didn't found the map, but I know that there are some maps out there that cost like 40 euros a month with just lost places in Germany, and it should be a really good map, but I just have to buy it for 40 euros a month. Maybe that would be a good investment, and then just taking out a few places, then to those places you can also see those places, you also get the information, a Facebook group of people who also were there and they rated those places. And that is what I would be doing, but not just going there to eat something. Eating definitely, but not just going there to eat something. Unless it's something really cool that you can't get anywhere else in Germany. So from here to here we now have 4.875. And then we have the same thing here, 4.85. So yeah, this line there we will just delete it because it's not serving any goals. Remember to always save, and then also we want to scale those to 0 to have them always drag along. Oh wait, we could add some constraints, I think, in the height, I think, right here. Constraints vertically here, this one and this one. Oh, nope, that's not what I meant. It was what I meant, but I don't think it's working like that, because you first of all have to center them or put them on the same height, and so that would eliminate the person. That would eliminate the constraint use case I wanted it for. So here just select here 0 again, just select. Let me select, can I know? So 0, so I couldn't select remove it because the constraint was still there. And there's a constraint, and there's a constraint, looks good. I don't know where the constraint down there comes from, but let's just let them. Anyways, I see that there are a lot of people watching right now, or what means a lot, a few people watching. If you guys knew, I would like a subscribe and a like maybe on the stream. You can also join the Discord server. In the next days I will upload there daily, or not upload, but I will make daily posts where I just quickly talk over what I did that day and maybe my to-do list for the days. So to just keep you guys updated on what I'm doing. If you're interested in that, you can join there. And also every week I upload Arduino tutorials about these little microchips. So maybe you're programmed with Arduino sometime in the past, but never really got to doing a lot with it. That is a cool series you can look at, where I cover all of the basic components. I almost got the most common out of the way now. Uploaded all the videos about that, and now I will go in a bit into more interesting sensors. For example, the video on this Saturday will be about here tilt sensors. So if you have a device that's tilted, pretty easy sensor, but if you want to know how it works, it's basically just a metal ball that's falling to the sides. But I will have a full video on Saturday there. And then next week I will have a tap sensor that detects if something is shaking or if it's tapped on the opposite. Really interesting ways they detect stuff. And in the future there will also be tiny gyroscope sensors. Basically I will just do a complete rundown of this kit right here. It's the 37 sensor kit from Allego, I don't know. And they have a lot of sensors in here, which are all really interesting. And I also covered a few of them. So if you're interested in that kind of stuff, you can just take a look at that series that I have there. So now we have the holes defined. We now just need to also say that the holes here are on the same height, which doesn't look like it. Why aren't they on the same height? Okay, I will move the constraints again. They're stupid. They're doing weird stuff to my sketch. Yep. No more constraints. So if we now go ahead and make another pocket, say that it should be 8 millimeters deep, then we will take a look at our other screws at the pocket and see that it's also 8 millimeters deep. Then I will no. Okay, so I didn't do that. Okay, how many steps did you have yesterday? I mean, it's you actually walk a lot, so. If you can hold it up with 20 steps a day, then my respect. Okay, let's go. So the screws are in. The next thing that we need is deleting the old screws because they're inside of our sketch from before. Then we have our sketch which is the motor carve out, probably completely spelled wrong, but we're just gonna go over that right now. Yeah, understandable, but only 11,000, so he got 20,000. That's why I said you can't hold on to him. So those are the screws. Screws like that. And there we go. If we now make another sketch and here make our references again, here this one and this one, then we put it like that and that, or carve outs. I would have liked to open that in another folder. I can still do that. So then it will be easier to look at the values from that. Just have to open another program then. But that should still work. So there we go. No, that is what I want. Okay, now it's opened twice, but yeah. So if we now go on the bottom, I want to see the triangle holes. Their sizes are bottom RB2, don't need that. I want, oh no, I need that one. That was a mistake. That was the wrong one. I accidentally closed the wrong, I thought it was the same, but it was not. This is what I need. That is the actual window that we want to work with. And here we go. So we see right here we have our constraints in the motor mount. We close that one because we want to put full focus on the triangle holes, which are this part, which are 2.5, and again 2.5. Then in the height they are 6 and 6. And then from that to this side they are 9 millimeters, I think. Here and here 9 millimeters centered. Close that out again. Click on remove 5 millimeters and we are fine with that. So we just have our next motor mount up here. Motor goes on here and we're fine. We are fine. I think that looks a bit clumsy with the robotic arm having this kind of shape there. But maybe this looks better as soon as we put the motor in. Maybe we can also round it later, but this will then also give less stability to the print. Yeah, have to see how this works. So now going to the bottom. First of all, calling this gantry angular hold. There we go. Now what we have to do is make a few sketches for the motor top. For that I will just take my little block right here. And I will just go ahead and switch the camera again. There we go. Where is my pen? Here, I'm just blind. So robotic arm, we have the tooth of May 1224, and this sketch will be about the joint 1 motor fastener, something like this. So what I mean by that is, you see the robot, the servo motor, and on that we have to mount the robotic arm. So we do that by carving out a hole in the sensor, in the motor, in the first joint, and there we will stick this shape here inside of. And I think we're gonna do that by having our joint down here. Then we will have a box in here. And then this box will be extended to the end with the last size. Something like that. So to now measure that, we need to go ahead and get our radius of which is 50 millimeter, 15 millimeter. So 15 millimeter. And the same then goes on to the side, just so that I wait there until this half. We will give it 18 millimeters. In that height direction, because you see it's not like going directly as my drawing is going, because I will create two rectangles, one on top for the circle and one on the bottom for the lower part. And this lower part isn't directly going in the circle because it's like a bit shaved like this right here. You can see it in the camera, it's just so blurry. Anyways, so I need to give it a bit more space. Its overall length is 35. If we divide the around 20 millimeters, but 35 will be the whole sketch. We just mark that. Make it 36 millimeters because it was 0.5 or something like that. And then from here to here, the size is 7.9 millimeters. Hoppa. 9 millimeters. So we will make that 8 millimeters for easier representation. Now we go ahead and so we have the 35. From the 35 we divide 18. We subtract 18, and the rest now here will be 17 millimeters long, just like that. And then we have our basic shape that we can also test before we draw anything. This whole thing will be 35 centimeters, and then if we add the 4 millimeters radius to the sides, we should be fine. So you have to imagine now we are not putting it also on the bottom here, but we're putting it here. So we have our one motor, sorry I didn't show it, we're not putting the side also down here, but we're doing it off here to have it a bit of balance. Because if you imagine you have your robotic arm which goes in like that, then the shield goes in like that, but isn't here directly in, but because it's like inverted, the mount is here. So the robotic arm will be a bit above the servo motor, which gives it a bit more balance. The center of gravity will be better. and then the same goes up here. The servo motor will be mounted up here, so it won't be one servo motor here and the other will be mounted up here on the other side, so it directly has a bit of offset there, so they will be quite over each other for better stability. And then the same goes up for the next ones too. So what we do is we give the whole thing a total of 40 millimeters in length, and that is already worthy to go into the folder below. One thing that we forgot to measure is the depth of those. Which is 6.2. Then we, in a second, we also have to measure where the holes actually are. I think I don't have to measure that myself because they have online on eBay where I bought them. They have their diagram there of all the sizes. So let's just take a look at my previously bought. There we have the stepper motor. And then we are just gonna take a look at the diagrams, which of course they haven't provided any for the mount. It's awesome. Maybe this other stepper motor has just like the same 40 kg. Yeah, that's also a bit more than my current can take. But how much voltage does it need? And it only rotates 40 degrees. Yeah, 180 degrees. Yeah, I think this doesn't even it doesn't have any diagrams. Okay, so I will have to measure that actually out myself. But first I will check my 3D printer again to see if there's anything changed. Our 3D print is done. See it right here. Funny thing is I didn't even notice that 40 minutes are gone. Like 1 hour of streaming are already gone. Let me just see. 1.5 hours already. Yeah, okay. Anyways, so when we now want to assemble this part, we now can just go and stick it on like that. It fits perfectly on that, doesn't have any too much wiggle room on those sides a bit, but all of that will be gone as soon as the screws are in. Now if we want to screw everything in, we're gonna have to choose our screws, which I said would be the 4 millimeters. the 8 millimeters. Just put 4 of them here. 1, 2, 3, 4. Then we need we don't actually need any nuts. We just need our plates right here, so that they have a bit more grip. Our washers. And now to assemble everything, we're just gonna go ahead, take our 3 millimeter kind of screwdriver, I don't know what they called. First of all, we're gonna assemble all the screws together here. Just gonna put those washers on top of the screws. Put everything together. Like that. Yeah, come on, get over it. Like that. And now as soon as we put on the motor, oh, that's so cool, it fits perfectly on there. And now we just have to screw them in. Okay, this one should be tight enough. Perfect. Then the next one goes in here. Oh yeah, now it fell out. So there we go. Just screw all of that in. I don't know, I'm not too convinced of the strength right now, because they slide in quite easily. So maybe I have to remove like 0.1 millimeters there. So like that. And then on the other side also tightening everything. I think the better thing would actually be to just take a bit longer screws and then maybe even taking those screws making the screws a bit longer, taking the longer screws, and then just driving those screws through the whole thing and making the might be even able to tighten them on the other end if they're needed. But it's quite tight on there. I mean, we won't know until we... No, perfect. Here, if I hold it on that, it's not wiggling around or anything like that. Quite tight on there, actually. So if we would take the bit longer screws, I think they would also work. I mean, there then would be looking out a little bit on the other side, but not enough to interfere with the robotic arm. So then I'll actually think I will actually here go and make the screw through all. through all. There we go. And I think with that we have our motor mount done. Can I still... I mean, the problem is here now, if I screw them too much in, they don't have anything to hold against them other than the material, the 3D printing material, which if I rotate them too much on the spot, it will wear down and won't have enough grip to hold the screws again. Then at some point, if you move the 3D printer, it might break. That's why metal is used for that kind of stuff. Or maybe there are some, I don't know how you call them, but I saw them in a lot of print or a lot of builds where people build some more precision objects, like 3D printers with 3D printers, where the screws needed to be very tight in there, and they didn't want to make this all the way through that you can make like a counter screw. They used like a, here the thing, how do you call it? Soldering iron. Soldering iron to heat up the material and put like the pre-made screw, what do you call that? Pre-made screw thing in there, screw hole, which was out of metal or zinc or I don't know. And then they could just take a put the screw in, because it was very easy to, or it couldn't stick out because the metal was ingrained in the print. I think you know what I mean. So the only worry I have right now is that, I mean, I have to print the arm on that side, but on the other side I also have to print the arm. So what we could do is either make the triangles also all the way through, which I think I will try. Triangles. So I can make this part upside down, because this don't necessarily needs to be only through the half of it. Also this will go through all, and now this one will go through all screws. And there we go. Now what we'll do, so we will select this face up here, click on extrude and say 4 centimeters. Then what we will do is create another sketch for up here. Then we will take a reference point from the bottom, and we will say that it goes like that. The height is 6 millimeters, 20. Let's give it enough room. Let's make it actually 18, something like that. And the width was 30. 30 millimeters, like that. So now you have that face selected, you go back the 40 millimeters, and that is our robotic arm, which is, yeah, don't know if that's enough space there, but we will try it anyways. So now we have our point there. We will make a reference point here, here, and then we will start to create For rectangles we use the center line. For rectangles. And then we'll use the edged rectangle like that to display this. From here we now have our values taken from the motor. We will have to quickly have to take a look apart the arm so I can measure the holes. I take apart the mounter there to see the holes. Also this side. Like that. Now that is the mounting port. We have the total length of it, which was 36 millimeters. We said. Kind of fits, it's a bit less, but it's not worst thing. From there to this hole it is 4 millimeters there. We have our big hole back here, and then we have two holes in the front. You see one on the back where the motor, the mount is screwed into the servo motor. Then we have two additional 3 millimeter screws on top of here, and those will need to be modeled on the arm itself, but we will do that in a second. First of all, we are defining the sizes of this stuff right here. Diameter was 15 millimeters. This one will be rounded to 8. And then we will have 8 minus. Okay, so we have this again. 15 divided by 2 is 7.5. 7.5 minus open brackets. No open brackets. I can still make 8 divided by 2, which equals 4. 3.5 is our sizes right here. From here is to there is our 3.4, which should fit on there. The height from that point is 18 millimeters, and the height here is 17. From the top plate it is 40 millimeters. We will give this point to this point foil form. -4. -4 millimeters like that, which means it hits the back down here, kind of. So there will be the main part in. From the center, this one is 50 millimeters, this is 13. 11.5 minus 15 is 7.5. So we should have from here to here 7.5, which perfectly fits because we already have centered this rectangle before. Now to scale out of our measurements to be able to read them better. And there we go. Now if we close this, this will be the motor fastener hole. We will go ahead. It is, one part is 4mm wide, so we will take those 4mm. 4mm. Let me see if I can combine these two parts, and I was able to do that by this. So if we go back, we have a clean edge right there. There we go. So I don't think we actually needed all of that space. How much space did I give it? Way too much at least. So this pocket was, no, not this, it was the sketch from the top. It only needs the 25, no, not 25. Let's give it 26, 24, 23, like that. There's enough space to the bottom to mount the screws. For that we will, for the motor I used an 8mm screw, but I think the 12mm still fits into the motor. Just see that it already gets a bit loose. 12mm. The 8mm, okay, it's about 8mm deep in the motor. If you stick then on top this part, if you then have the 4mm there, then there will be another 4mm down. About 7mm we can divide from that. 3mm, so 7 there, 5mm to the top. So this can actually be the full 20. Should be good space to have another lot of grip down there, because this part will hold the complete robotic arm. So now what we can do is not just can, what we will do is, I think we first of all are going to remove or make a bit more space here, because I don't want this to hit anything down there, and rotate it. For the arm from here, from here to down there, will be around I would say it should be 55 deep, but 60 should be. Oh man, so let's just see where the problem lies there. see it. This pad was extruded too long. D5 and should be halfly good again. Now it's just extruded up. The thing is, I want this whole part to be a bit smaller than. This only is 80 millimeters, which means it's 20 millimeters shorter. It's about the size that we removed there. So now when we go back to this sketch right here, we can tell it that it should have a vertical offset here of 0 from this point to this point. It should be 0. And this point right here also should be 18 millimeters. Should be 18 millimeters long. And then I see the problem there. These points are not connected. Can I somehow remove that point there? How can I merge two lines together? Point. Oh. Those two lines on equal length. Gradient. Let me just take a look at YouTube again, how to in FreeCAD merge two lines. Love that guy. Again. I mean, it's the perfect dude. I watched every single tutorial there. I watched so many tutorials on FreeCAD. Many tutorials helped me, but most tutorials came from this guy. There were like 2 tutorials that I watched in the last streams that helped me from other guys or that directly showed me what my problem was. But this guy always showed me. If I watched at this channel, he always helped me.
To join lines. Okay, in here you can create new drawings and check body, top draw line.
Let's see.
Create 3 lines in here. Use these tools. Constraint coincident. You can click from this line point into here. I will connect again from this point to here. And then next you connect.
Okay, my screen is bugging out, but I think he helped me again. Let me just see if I remove those lines again. And I click this point and this point right there. And this point and this point right there. It is the perfect shape. Woo! Hey man, I have to join this. What does this guy everything sells? What is he up to now? He made those tutorials last year. LibraryCAD, how to parallel lines. He still uploads tutorials. What a top G. $10 a month. Okay, I will see if I join him later in this, but I will write a quick comment. What a guy. I love that guy. Man, it's so cool. Okay, so we have our arm here. The total length now should be, oh wait, this should be 70mm. This right here should not even exist anymore. Zero line. And now we have the not merged again. Wait, if I now go ahead and change this side from no. As long as it still works, I'm happy. So now we select this face. Oh, and this is again the, what I call it up here, motor fastener carve out. That's perfect. So now we select this face, make a new sketch on it. Then we go here, like that. Then from, just see what the sizes were here. So from the center, I mean it's hard to four millimeters from there. First of all, I have to export, not export, get this line right here again. Oh yeah, it's actually that one right here. Didn't even notice that really. Nope, we want to have the vertical from here to this point. It should be 4 millimeters. From this to this one. This one should be another 4 millimeters. And from that point that is 20 millimeters. Perfect. So we have this size, this one and this one. All of them need to now just be sized in the right scale, which is 3 millimeters, 3 millimeters and 3 millimeters. Now we can exit out of here and just say here, carve out through all. That are our holes where we stick the screws in. Now what we will do is we export it, open Cura again, because usually it takes this time, as we know by now. First of all, we need to select the body, export, and that's no longer a test. Exports, and that is the joint 1. Cura is already open. And then we will go into the exports, joint 1. Just quickly slide the SD card in for the 3D printer. Then this will be rotated 180 degrees, and what direction is that? The green one, let me see that in a second. Three and a half, almost 4 hours. Yeah, it's fine. So now what we do is we click on, just check if everything is fine like that. Yeah, those holes need to be printed. And then we click on save to SD card. And then I'll directly export it. Not export it, directly go ahead to the 3D printer and print it. So I have this done today and see later if it works. So now there is the 3D printer is going, hopefully by now. For today I think we got a lot of the stuff done that we wanted. The main thing that I wanted to focus on was here the arm, that we get the bottom to completion in the prototype. And I think we got that by now. The thing is, we now just have to add this object on top of the folder. On top of the motor mount. To do that, not the Notion. To do that, I just have to open my project here. Then I open the base plate in this base plate right here. Delete the rings, no longer needed. And then we also open the motor mount real quick. And then I hope that I can just take that, copy, go over to here, and just click on add, base plate, Hoppa, nope. Yeah, no, that's sadly. Oh, no, I completely destroyed that one now. You know, I think I will just model that then myself. So I will select this face, say that I want to model on that. Then we export our field right here, or these points. And we are going to make a quick rectangle right here. Something like that. Close to the center. And then what we are going to do is, we're not doing that on that center. Also not on that side, because if I print the motor later, it will be easier if I am on that side. So here we want to create our rectangle. So there we click 10. Oh, why is that now? Hello? So let's see. We can select it there again. Remove those two constraints now. Don't want those constraints. So we are just selecting that tool, and we are saying hello. What the fuck? Here to here it's 12. Why is? Oh yeah, okay. I get it. I'm sorry. Because I rotated the thing, the tools won't rotate with me. So if I have it like that, the tools are 0. No, the tools here. The thickness was 8.5. And the length is 30. Now I will exit out and I will click extrude. I will extrude this for 60 millimeters. Then on that side I will go ahead and create a sketch. That sketch will be the center right here. It will be 20.5 millimeters, and there will be 40.5 in height. The motor mount, if we take a look at our bottom, we have 40 millimeters. So we had this already, this calculation. Let me just see. I hope I wrote it down here somewhere. I won't have to do it again. 50 millimeters, of course I didn't wrote it down. That's perfect. So basically we have our 40 millimeters right here. We have our 60 millimeters right here. 60 divided by 2 is 30. 40.5 divided by 2 is 20.5. 20.5. Oh, I wrote it down. 20.05 is, wait, it's 9.75, and in the width it is 4.75. Or is it 30, 15, 10.25? If I now go ahead and check this side, it should be the same for this side. So going ahead and checking this point to this point, it is the perfect size. So that means we can move on by carving out the rectangles. One thing triggers me that this is not in the center. Anyways, so we go ahead by creating these rectangles first. Triangles, there are 2.5 wide. 2.5, 2.5. The height was 6 millimeters. So like that. Now we had our holes, which were right there. Right here, 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 and here. Before I will tap that in, I will try to go ahead and see if I can apply this also to this. That's fine. This blade. Now if if I can go ahead and select this face and select the screws, and I would hope that I can nope, that doesn't work. Anyways, so we are going to make the screws again, which are all 2.9, 2.9, 2.9, and another 2.9. What was the last thing I modeled? It was this one right here. There, the screws. Let me just take a screenshot of that. This will be much easier. Had to open it again. So now going on our other plate again, we'll go base plate, sketch 1, and first of all we have our frames like that. They are from here to here, 10 millimeters difference. The height difference should be 0. Same goes for this one down here. 0 height difference, and the length between them, or the width between them, is 10 millimeters. Then the length from the left one to the corner there is 5.125. Same for the one up here, 5.125. We'll just quickly try to make this a bit more readable. Oh no. Also, I didn't. Okay, I will take a look at the center of those parts for in a second. Let's finish this thing here first. And the difference in height should be 4.875. 4.875. Then if they are all set to 0 and finished, I will just go ahead and try to apply the carve out filter already and hope that I can just select through all. Okay, then I will not select through all. Okay, that means that I might have to remove those again, those screws. First thing that I want to do is I want to So let me just remove that one right here. And also the size down here. Before I do that, I want to quickly scale those to the right size. 9.25. Then just 9, or maybe not 9. Then this was... what was the center of those? Going back to those and taking a look at the triangles. Of course I didn't write it down anywhere. So the center from the right, we have here 25 millimeters, which is 10.25 minus the 1.25, which is equals to 9, but this is not the center, which could explain why this isn't working as I wanted to. That fits. 9 fits here as well. But this is not the center. This to this, that might not fit. No, that's fitting as well. Then I have no idea why this isn't centered. Maybe it's just a visual thing for me. 575. That looks centered to me. I don't know why that wasn't centered. Oh, 8.75, like that. There we go. And now what we want is we go up here and we will take a look if we can remove those surfaces. Don't piss me off, please. And I think I have to come eat in a second. But first of all, I need to finish that. Other than that, I don't have any peace while eating, because I'm just so good at it right now. And this looks good until you have it finished. Perfect. Works. So let's just see if I have the sizes are here correctly, like that. They're centered, kind of centered. Just select a point here, and if I go from here to here, 4.5, from here to here. Oh my god, this line is not centered. 15.3. Oh god. Yeah, no wonder why this all was offset. Okay, let me just fix that real quick. I'm just going to the sketch right here and moving all of that really nicely to the center. I'm having the distance from here to this point, from this point 0, which I cannot have. So we have here 0, and then we have in the height 0, Now when we go back, we should see that, look at that, we should have 9 here, that is centered, perfect. 9 here, that is also centered, which means that now this should work like it should. It should work like it should work like it should. So, damn, how long did I stream by now? That's perfect. Now I don't even have to go outside because I have my food right here delivered. Good stuff. So this should work. If I click live again on my video, my live stream, 2.5 hours. So as we can see, this part should be finished so far. I might be thinking about some added support right here, but I think I will worry about that later. Motor goes here from this side, then the first arm here, and then the second arm on top, and then you can move everything around. In theory, this should work, and in practice, it will work. And if it doesn't, I will have to make it work. But because I streamed now for so long, my head is a bit broken. Not broken, but I slowly run out of the capacity to speak English fluently. Not that I ever had that too much, but you get my point. So the most important tasks should be done by now for today. As I said earlier, my most important task was to get the base plate ready together with the motor mounting, with the motor mount. And we actually also got the first arm fertig, fertig, right, there you see it, I'm starting to speak German again. So we got the first joint finished. So yeah, a lot of work done. I hope that this works like it is supposed to do. If not, might do a stream later today if I have recovered my brain from that long stream, or at the latest maybe tomorrow. Tomorrow I might even do that a bit earlier in the morning, because I usually wake up at like 5 or 6 a.m. to start my videos, recording everything. get everything done for the day. And yeah, then I guess I see you guys later. Thank you for watching. And again, just a quick ad here. Join the Discord server if you enjoyed this stream right here. I will upload daily posts on there where I make like kind of like little vlogs, maybe not in the long form, but just some short update that you guys know what I worked on today. I will post here my to-do lists maybe, so you see the behind the scenes of those streams. And I mean, there's not too much behind the scenes of the streams, but I mean of the videos, what I do, what goes into those videos that I make. If you enjoyed that and maybe want to start some channels like videos like that in the future too, just join the Discord server. We can have a little talk and chat a bit, and just to find like-minded people. So then with that, don't forget to like and to subscribe, and then I see you guys in the next stream or in the next video, where you guys want to see. And if we don't see each other again, have a good rest of your day and the rest of your life. See ya, bye bye.